Alright, so for number 35, they're just asking you to add the two functions. So f of x and g of x. So we'll take 2x minus 3 plus 4 minus x. Combining the like terms, so 2x minus x is x. 4 minus 3 is 1. And there's the answer. They're not asking for domain on this one, so we'll just not answer that. 36f minus g, so be careful with your negatives. So 2x minus 2 minus 4 minus x, so you distribute the negative. So you get 2x minus 2 minus 4 plus x. So 2 and 1, that's 3x. Minus 2 minus 4, that's negative 6. So that's number 36. For 37, we're multiplying. So f of x is x squared. And g of x is 7x minus 7. So you just distribute the x squared. So that's going to give you 7x cubed minus 7x squared. Number 38. There is a domain there that they're asking for. But first let's do f divided by g. So f is x squared and g is 7x minus 3. Okay, so this is the final, this is f divided by g of x. Domain, remember the denominator cannot be 0. So we said 7x minus 3 cannot be 0. 7x cannot be 3. Divide by 7, so x cannot be 3/7. So domain, all x such that x cannot be 3/7. Alright, for number 39, f divided by g of x, so we put 1 over x squared divided by 1 over x to the 4th. Remember, when you divide a fraction by a fraction, you multiply by the reciprocal of the denominator. Oops, x to the 4th over 1, like that. That's multiplication. So you're left with x to the 4th divided by x squared, which is x squared. So if they wanted the domain of this, remember x cannot be 0 because the original functions, we could not have 0 in the domain. So the domain for this one, I know they didn't ask for it, but you would, if they did, on the test they could ask, it could ask you for that. You would say all x such that x cannot be 0, even though like x squared seems like, you know, it would be okay, but we came in with a domain that didn't have 0 in it. Okay, so we have to keep it that way. Number 40, you are evaluating, so it's up to you if you want to evaluate f of 3, g of 3, and add them together, or if you want to first do f plus g, simplify that, and then evaluate it at 3. I'm going to do f of 3 plus g of 3, the second method in your notes. So f of 3 would be 3 squared plus 2, again I get that from here, and then g of 3 would be 3 minus 4, and I get that from here. Okay, so 3 squared, that's 9, 9 plus 2 is 11, 3 minus 4 is negative 1, so the answer is 10. Number 41, this one I'll use method number 1, so I will first do f minus g, so that would be x squared plus 3 minus x minus 6, and again I'm just randomly choosing the method. X squared minus x, this is plus 6, so 6 and 3 is 9, and so now I'm going to evaluate it at 0, so 0 squared minus 0 plus 9 is going to give you 9. Alright, so for 42, I'll use the first method in the notes, which is first do f minus g and then evaluate that at 3t. So f minus g would be x squared plus 3, that's f of x, minus x minus 4, that's g of x. So I get x squared plus 3 minus x plus 4. So that gives me x squared minus x. 3 plus 4 is 7. So now I'm going to evaluate it at 3t. Okay, f minus g of 3t. So this is 3t squared minus 3t plus 7. It's a funny looking t. So the final answer would be 9t squared minus 3t plus 7. For number 43, I'll use the second method where I do f of negative 5 minus g of negative 5, just again to show you the different ways you can do this. So f of negative 5 would be negative 5 squared plus 2, and I get that from this, minus g of negative 5, which is negative 5 minus 6, and I get that from here. So that's 25 plus 2, 25, so that's 27. This is negative 11, but there's a negative in front, so it becomes plus 11. So that's 38. Alright, so for 44, we're doing composition, g of f and f of g. So I'll start off with g of f. Right here. So that means that this is the inside function, and so g is the outside function, so I set it up minus 4, and in the parentheses inside I fill it in with f of x, like that. And there's nothing much to do here, just get rid of the parentheses, and this would be the answer for g of f. F of g, g is now the inside function, okay, and that's the one that's going to go inside of f. So f is x squared, so it's going to be like this. That. And in here I'm going to put g of x because that's the inside function. So x minus 4. So remember the OOPS worksheet, okay? This is not x squared plus 16. This is x squared minus 8x plus 16. Okay, if you don't know how to get this quickly, that's okay. Just write it out. X minus 4 times x minus 4. And you'll get what I have right here. Number 45. It says find f of g and the domain of the composite function. So this is the inside function. So we're coming in with all real numbers, okay? Coming in with all real numbers. So you're going to take square root in place of the x. We're going to replace that with g of x. So that's x squared. And so this becomes x squared plus 5. So the domain, there's nothing that would make this a negative number. Nothing. There's no real number that would make this a negative number because you're going to square it. No matter what you start with, you're going to square it, make it positive. So then the domain of this composition is all reals, because no matter what, you're never going to get a negative number. You would need a number smaller than negative 5 to make this a negative. So since that's not going to happen, here's the composition and here's the domain. For 46, find g, f of g and the domain of the composition of the composite function. So g, again, the domain is all reals. We're coming in with all reals. Okay? That's your inside function. So when we do f of g, f is our outside function, so we're going to write the outside function without the x. In place of the x, we put in the inside function, we substitute like that. Okay, it's not a 2, it's an equal to that. So you don't need the parentheses, so you could just write it like this. So this is f of g, and the domain on this one, all x such that x cannot be -7, because -7 would give you a 0 in the denominator.